Hello all, it's still your favorite physics teacher, and here we're going to keep talking about video number 3, vectors, except now we're going to do this a third way, well actually really a second way. Video number 1, we saw really easily how to draw a vector. We know a vector is a representation of specific things in physics that have both a magnitude and a direction. And again, a vector is something that we draw with an arrow that has a very specific tail, a tip, and we draw components tip to tail, whether it is a real vector diagram to scale or just a sketch. You can say here this was just our sketch. Here I tried to show that order doesn't matter. If we had the 3 meters per second, the 2 meters per second components, that was 5 meters per second east. Same thing, 2 to 3, 5 meters per second east. Then we drew a quick, easy scaled diagram with just 2 different directions. Then in the last video, we went through a little bit more of a complex situation with 3 different directions, where I started here, went that way, came back, ended here. I drew my resultant from start to finish. Here we're now going to look at the exact same problem, except we are going to do it just mathematically. So it is just a sketch. All I need is my calculator and my pen. So it says a person runs 5 kilometers north. I'm going to start with that. I'm going to say, hey, this person went, I'm going to put it all on the one side of my page. Number 1, I just went 5 kilometers north. And that was it. So there's my sketch, 5 kilometers north. So I'm going to put a number 1 over here, and I'm going to label things in the x direction and the y direction. Now my x direction, I went 0 kilometers because I went 5 kilometers north, and I know mathematically north is y. So we went 0 kilometers in the x. I went 5 kilometers in the y. That was nice and easy. Now, spot number 2, and I will say spot number 2. I turned 25 degrees west of north, and then I ran 8 kilometers. So I'm going to have a starting point here. There's my compass. North, south, west, east, and I went 25 degrees west from north. So just that direction, which means my resultant, that is just going right that direction. This is my 8 kilometers. Now I could have made this bigger. Actually, I'm going to make it bigger just so we can see it. 8 kilometers, and I know that this is 25 degrees because that was my direction. 25 degrees west of north. So here I have a y and an x portion or component to that. Well, we know, because we've done trig for so long now, that I can find x and y by doing trigonometry. Now, I could have also done its complement. If I know this is 25 degrees, I would say 90 minus 25. I know this angle here is 65 degrees. And notice, look, I would have the same thing. I'd have an x going this way and a y going that way. That's called a parallelogram method in your textbook. But either method is valid. And we would find our x and y components no matter what the exact same way with right triangle trigonometry. So I'm going to use what they gave me in my question. And I'm going to say the sine of 25 degrees is equal to opposite, x over hypotenuse, 8. And then I'm going to say the cosine of 25 degrees is equal to adjacent, y over the hypotenuse, 8. Which means to find x is equal to sine 25 times 8. And my y is equal to 8 times the cosine of 25. Again, order doesn't matter in multiplying, so I just say 25 times the sine, whoop, that's wrong, sorry, sine 25 times 8, sine 25, so for my x, that is 3.38 kilometers, and my y, 8 times the cosine of 25, is 7.25. Y is equal to 7.25. So now I'm going to put that in spot number 2. I had 3.38 kilometers and 7.25 kilometers. But I need to be careful because in physics it matters. Notice this direction. That is going in the negative direction. Y is going in the positive direction, which means this is a negative 3.38. That's a positive. Now for spot number 3, I look at my final 10 kilometers. So my final 10 kilometers were 55 degrees south of east. So again, I'm starting right there, and I went, this is my east direction, south from east. So I know my vector is going that way. 10 kilometers, and I know this is my 55 degrees. Again, oops, sorry. I know this could be the complement if I want of, let's see, 90 minus 55, 35 degrees. But I'm going to use the angles they gave me. Again, I'm going to force this to be a right triangle where that's my x direction. That's my y direction. And for my x, this is a little bit different, a little bit confusing. Is why I chose these directions. Now, instead of x being sine, x is a factor of the cosine because that's my adjacent. So my x is equal to, it's the exact same method, cosine of 55 times 10, my hypotenuse, and my y, this time that's the opposite, so it's sine of 55 times 10. Cosine 55 times 10, that is 5.74. X is equal to 5.74 kilometers, and y is equal to the sine of 55 times 10 is 8.19 kilometers. 8.19 kilometers. And now I'm going to show you, I notice that this is going down, so the y is negative. The x is positive because that's going to the right. So my x is 5.74 kilometers, and my y is negative 8.19. So now what do? Now I add up all of my x's and all of my y's. 0 plus negative 3.38 plus 5.74. 0 plus negative 3.38 plus 5.74. My x direction is 2.36. Positive 2.36 kilometers. And my y direction, 5 plus 7.25 plus negative 8.19. That comes out to 4.06. Positive 4.06 kilometers. Well, what is that exactly telling me? If I look, this was my resultant. It was in the positive x and the positive y. Positive x. So far, so good. It looks like it's good. What this looks like is now like almost a brand new problem. I have a sketch that is going in the positive direction, 2.36 kilometers. And in, let's do that again. 2.36 kilometers. And then the positive y, 4.06 kilometers. My resultant is that. I'm going to label it R. We know right away, we knew before the beginning of the school year, I could solve that using Pythagorean theorem. The resultant is the square root of a squared plus b squared. So I'm going to say the square root of 2.36 squared plus 4.06 squared. 2.36 squared plus 4.06 squared. Now, if I did it correctly, it should be about 4.7. 4.69, that's great. So my resultant, which is the displacement, and it actually rounds to 4.7. 4.7 kilometers at, I need this angle. So if we did my scaled diagram right, this angle should be approximately 60 degrees. Now, because this is what I had, my x and y components, my angle is going to be the tangent of opposite over adjacent. 4.06 divided by 2.36. So that means theta is equal to the inverse tangent of 4.06 divided by 2.36. The inverse tangent of 4.06 divided by 2.36. 59.8 degrees at 59.8 degrees. And again, I know it was in this direction, so it would be north of east. North of east, which is almost identical to my scaled diagram. So those are all of the methods of which we can draw and solve vectors. I hope this has been informative. I'm sure there'll be more videos to come. If there are any questions after video number 1, number 2, or number 3, by all means, send me an email and I will get back to you. Thanks so much for watching. You'll see me all soon.